next speaker is Nabeel Siddiqui from Susquehanna University, and his title is Bipartite Frame Networks in the Analysis of Film, a case study utilizing commercial computer vision APIs. So Nabeel, the floor is yours.
Thank you. Okay, let me just share my screen real quick and then we'll get started. Hope everyone had a wonderful lunch as well. So this is a project that it's more of a methodology that I'm trying to explore. So I'm using it to analyze film, but it can be used to analyze a variety of things. So it's basically the ways in which network science can help us understand annotations after we've done them, and and also how these annotations can be done, and what the benefits are of using commercial computer vision APIs rather than some of the open source ones. Um, so this is part of I've done a research paper on this for the Journal of Open Humanities Data. So this is kind of a shorter version of it. And it's called Cutting the Frame, and it looks at Hitchcock films. I'm just going to go through sort of 4 parts in this talk. One, I'm going to talk about data gathering, basically how I take the films and make them able to be annotated. 2, why I use Google's Vision API and some of the challenges with that for reproducibility, but also some of the benefits that it has that really open source annotations probably will not have. What a bipartite projection is, and so this is the network science once these annotations are done, and then a little bit about what are called backbone networks, which people in political science kind of use, but not a lot of humanities scholars have used, and why I think they're a useful tool for looking at these annotations after they're done. Okay, so for data gathering, the largest issue is copyright. I'm in the United States. They recently allowed people to hold certain films for research purposes. So this might not apply to everyone. Basically, the collections I used was the Alfred Hitchcock Ultimate Collection DVD. This has about 15 films and 3 or 4 um, television shows that Alfred Hitchcock did. And so I basically just focused on the films. Once you get the DVD, I put it, I scraped the MKV files from it and put those on a secure hard drive that only I had access to. I kind of talked with my library to sort of discuss how to do this. And so this is no different than just kind of scraping the video off of the DVD. And so I had 15 of these. Now there's a problem with 15 films because to annotate them with vision, any kind of computer vision, you need to get frames. So there's a couple of ways that you can get frames, I'm calling this sort of frame overload. So once you get the film files, there's issues of how many frames you have. I'm calling that frame overload. So there's a couple of techniques. One is you can do what's called shot boundary detection. Shot boundary detection looks for shots, and there's various algorithms that will look at shots and determine where they exist, and then you would just get a frame for each shot. Certain Alfred Hitchcock movies can't do this because they're known for having long shots, and so it wouldn't really work in this scenario. You can also do what's called keyframe extraction. These are sort of tied together, but keyframes have more to do with how the storage is done on the computer itself, and it's how the computer plays or any kind of video kind of plays. The technique I used was just a simple technique, which is time-based extraction. And this worked well for films of Alfred Hitchcock because, again, he has some very long shots. So basically, I just took a frame every second. And so you get about 105,000 frames out of the 15 films. Okay, so you just get frame one, frame two, frame three. And the benefit of doing that is you can also then get the timestamp, right? Because you're just getting the each second. So like frame one is 1 second in the movie. Frame two would be 2 seconds in the movie. Frame three, so on and so forth. Okay. So I got about 105,000 of them. Okay, to annotate these and why I use Google Vision API. So the issue with so open source solutions like you only look once, or YOLO, right? Work really well, and you can train them to do a lot of stuff, and you can kind of fine tune them for a particular data set. This would work if you had just sort of one film, but my idea is that you could do this with a lot of films. Now, Google Vision API is quite expensive. It cost about, for the 105,000 that I had, about somewhere around $1,200 or something like that. So this is very experimental, and you couldn't, and one of the problems with it is that its reproducibility is limited. And that's one of the reasons the Journal of Open Humanities Data published this data set, is because you couldn't get the annotations that I got out of it. Okay, so what's the benefit of using this thing? Unlike other open source unlike other open source applications, there are a couple of things that Google Vision does that other things will not do. And the main thing is web entities. So web entities, so you can see there's label detection, and this was from a article for somebody studying basically memes. And so this is common in sort of digital media research, but not in the digital humanities as much. So basically, they were looking at memes, and they used this kind of technique. So you see this label detection, and this is what would happen to each frame. So you get a label just like you would in any other computer vision thing. But you also get a couple of other things. One is this web entities. And what that does is it allows you to get more detailed descriptions about what's in the image based on Google's knowledge graph. So I think they have like 500 billion entities or something like that that they claim um, they support. And so you could get things about like Alfred Hitchcock, but then also kind of discussions on the web around Alfred Hitchcock and that frame or whatever's in that frame. So let's say there's a frame of the famous shot from Psycho. You could also see like sort of other topics around that, and those kind of manifest in these web entities. And then you can also get the matching image URLs. So let's say there's a bunch of people discussing this frame on like a message board to they're using this frame on a message board. Well, you could get the URL of that message board. You could see like which frames go to different websites and stuff like that, which websites are kind of the most likely to hold images of Alfred Hitchcock. You can also detect piracy with this. I found that a lot of the results I found were just people that had uploaded the movie on their like various drives or websites and stuff like that. That's not something that I'm particularly interested in, but it is something you can do. So you end up getting something like this. And so you can analyze the film, and then there's the timestamp. And then you get stuff like, face detection. So this has how likely the face is and the joy. And then you just develop what are called co-occurrence networks. So I'm just going to go through these real quick, and I might not be able to get to the backbone projection because I've only got 2 minutes. Bipartite networks are basically two types of nodes. They have a label and they have a annotation, or sorry, they have a frame and an annotation, and you just check the co-occurrence of the labels to see if they show up together. So what's flowing through this network is visual film narrative. And so here you can see like if faces that show surprise are more likely to show up together. So you can see that most faces don't show surprise and they tend not to be showed up together. But all these loops demonstrate that when one character or one person in the film shows a surprise face, there are other characters that also show surprise faces. So you can see a little bit about film narrative. And then you can see these label detections. These label detections are, not very useful this way. They have things like jaw events and gestures and stuff like that. And so if you just give me kind of one more minute, I could just finish this off. There's a problem with the web entities. There's just so many of them. So I use a technique, even if you filter out to just one film like Psycho, you'll see that they don't really cluster to anything that useful. So Alfred Hitchcock is over on the left, and then you have all these kind of things in the middle that say human behavior. So one technique that I'm using is called backbone projection, and this just finds co-occurrences that are statistically likely. And so you can see, let me just move to the web entities here, that now we see like certain patterns that show up together. So all the actors are in the left-hand side. The like cars and stuff are on the top, and on the right, you can see this kind of clustering of what I would call sort of film techniques. And so you can see the flow between them. So I think I'm out of time, but I'll stop there and take any questions. I'm sorry, I went through really fast at the end there.
Thank you very much. So, questions? Well, then it's my pleasure to ask the first question. Take the room here. I think this is very interesting, and I just was wondering if I understood it correctly. You said that at least some of these label detections at first were not that useful, but I was just wondering, have you thought about what would be your next step to make them more useful? Because I think that this kind of like network, looking at the network structures of what is in the films and maybe comparing between different Hitchcock's films, it seems to be to me kind of like really promising. So, but how would you can you share some thoughts about kind of like what is the next step of this labeling?
Yeah, so that was kind of near the end. Let me just share this real quick again. So I didn't get a chance to talk about it because I kind of ran out. So there's a technique called backbone projection. So what this does is you have co-occurrences, right? So one annotation, let's say there's like a table in one frame and like a person with a suit, right? So that's a co-occurrence. Now they might show up a lot together, right? Because each frame, like maybe that's just the setting of that movie. So what backbone projection does is it removes things that kind of show up together a lot. So it looks for statistically unlikely or things that are statistically significant. You can get like a p-value out of it. And so at the end of that, you remove a lot of the nodes that aren't very useful. And that's what I was trying to show at the end here, is that for the labels, right, when you do community detection, it is useful once you do the backbone projection. So you can see that there is a clustering of different ideas around the film. So over here, you see that there's a clustering of vehicles and things like that. In the web entity detection, you also see like a clustering of facial expressions, a clustering of events and music. So these are like kind of formal events in the film. And then kind of shapes and stuff like that. So you can see which one of these are actually useful. So it's in the first example, when I said that the label detection wasn't useful, it's that it's not useful unless you kind of do this additional statistical technique that removes many of the labels that just kind of show up all the time.
Thank you. Now I got it. Any other questions? Well, actually, I have one more.
Yeah, sure.
So did you look at kind of like compare the different films or are these kind of like aggregates of all Hitchcock's films that you studied?
Yeah, the first so I didn't compare films. I did the aggregate. So it was all the films together. But then I did look at the end. One of the problems with web entities is that you'll just get so many of them, and it isn't on like most computers. It's not really possible to do the backbone projection. And so I just focused in on Psycho as a film. So the last network that I showed you was about just Psycho, but the ones about the faces and stuff like that were about all of the films together. So I've done both.
Nice. Okay, so please join me to thank Nabeel again.
Thank you so much.